Hey guys, so in this video we're going to go over what is the circular motion, right? So that's going to be a topic that a few of you asked me there about in the DMs, being like, how do we understand circular motion? And this is something that you're still struggling with. Remember, we've got our cram courses the night before your exams and they're focused on AQA. It'll be 5 hours and it's only 20 quid. But hopefully these videos are also going to help you out. So again, what we're thinking about, you should imagine you've got like from your GCSEs, and you've got a ball and then have a spring, and you're twirling that spring. I just noticed I got ink everywhere. Twirling that spring. If you let go of the spring or the spring snapped, what would happen is that ball would move off at a tangent to the circle. So for example, if my string snapped here, it would move off to a tangent to my circle. If my string snapped here, it would move off to a tangent to the circle. If my string snapped here, it would move off to a tangent to my circle. So linear velocity is the velocity you've always talked about, right? We know that velocity, I can think about speed, is the distance traveled divided by time. So let's say we model it for a full circle. If something to go around in a full circle, the circumference of a full circle is 2 pi r, right? 2 pi times r. And the time to get to go around a full circle, or remember that's called the time period. So the time period is the time for one full circle, or one full revolution, or one full wave. So that's how we can write what our linear velocity is, 2 pi r over time. The angular velocity, exactly what it says, it's the angle it goes through at a certain time. So what we're thinking about is the angle it goes through in a certain time. So if it goes through a full circle, we know a full circle is my 360 degrees, but we can also write it as 2 pi radians. So 2 pi radians. So if I think about the angle it goes through, I can say that angle is 2 pi, and the time it takes to go through that angle is going to be, again, my full circle, my full time period, so that's going to be that capital T. And then we know from our GCSEs that 1 over the time period always equals the frequency, or time period is 1 over the frequency. So I can see here, because I got 2 pi over T, I can now write that as 2 pi times the frequency. So that's how we write our angular velocity. And our angular velocity, we give the symbol W, okay? So it's actually like a lowercase omega, but it's just, we write it as a W. So the angular velocity is 2 pi times the frequency. Okay, so what we can see now is the next question says the orbit or revolution. So you might see both of those words. One full revolution, just like a revolution's a full cycle, right? If you rev your engine, we're talking about like a full cycle. And orbit, again, an orbit, maybe if it's a planet, it's going in a full orbit around the sun or around a star. So let's say whatever the orbit or the revolution is, it takes 3 hours in time. So first thing I think, I never have time in hours, it needs to be in seconds. So I'm going to do 3 times by 60 to get it in minutes, times by 60 to get it into seconds. It says calculate the angular speed. So I want that W, the angle it goes through at a time, which I know is either 2 pi times the frequency, or I can write 2 pi over the time period. I want to know the centripetal force.